we will be looking at increasing and decreasing function. How to decide a function is increasing or decreasing. A function f is increasing on an interval I if you choose u more than v, then the function value at u is more than the function value at v. So on the diagram here, u is bigger than v, then you'll find that the function value at u is more than the function value at v. Yeah? And increasing function, you'll find that if you draw the curve, it's going up. It's going up all the way. Yeah? So a simple way to do an increasing function is bigger x value, bigger fx value. And we also say y increases as x increases. So as you go from left to right, the y value is going up all the way. So increasing function. For decreasing function, it's the other way around. If you have decreasing function, you choose u more than v, then the function value at u is less than function value at v. So meaning bigger x value, smaller fx value, and we say y decreases as x increases. Then you will find that if you go from left to right, the curve is going down. It's going down. So meaning bigger function, bigger x, smaller function value. So now the question is how to check a function is increasing or decreasing. And the answer is you will use what we're going to do now. If you look at what you have, what does the sign of m tells you? You know that when you look at gradient, when m is positive, the line is something this way for positive gradient. Then if m is negative, the line is something this way. For negative gradient, the line is something this way. And you'll find that if m is positive, you get increasing. You get increasing because y value is increasing. So y increases as x increases. And then for negative gradient, then you will find that y decreases as x increases. So which means the gradient or the sign of m tells you increasing or decreasing function. Positive gradient, y increases as x increases. Negative gradient, y decreases as x increases. And because m is actually gradient, and dy dx is also gradient. And when we talk about a point, right, the gradient at a point, you draw tangent line. So tangent line, if your tangent line is having positive gradient, then you will find that the curve is also increasing. Whether it's curving this way or the other way. So for both graphs, y is increasing. So which means if you have dy dx positive, you have y increases as x increases. You have increasing function. So it means if f prime x is positive, you get increasing function. Then when you have a negative gradient, it is pointing this way. So if you have a curve, if you draw tangent line, you get negative gradient. Then the curve will be decreasing. Whether it's curving this way or curving the other way. You draw tangent line will have negative gradient. And the same as saying dy dx is negative. So if dy dx is negative, you get y decreases as x increases. So if f prime x is negative, means f is decreasing. So to summarize, if f prime x is positive, then you will get increasing function. So if f prime x is positive for all x in the interval I, then the function f is increasing on the interval I. And if f prime x is negative for all values on the interval I, then the function f is decreasing on the interval I. You can write an x squared graph. For x squared graph, f prime is 2x. Differentiate x squared is 2x. So you'll find that if x is positive, 2x will be positive, then f prime will be positive, then f is increasing. So we can see if you look at positive x, it's increasing. And if you look at negative x, then 2x will be negative. Then f prime will be negative. F prime negative means decreasing, less than 0, right? Then you can see when x is negative, it's decreasing. The curve is going down. In this example, you are asked to prove that the cubic function 2x cubed plus x squared plus 2x plus 1 is an increasing function. And to do that, right, you can just differentiate fx to get f prime x. So differentiate x cubed is 3x squared and times the 2/3 will just give you 2x squared. Differentiate x squared give you 2x. Differentiate 2x give you 2. Differentiate 1 give you 0. And you can do completing square. After completing square, you will find that this term x plus half square is always positive or 0. So plus 3/4, it means it's always positive. So we can say f prime is always positive. So f is an increasing function. So you can use dy dx of f prime x to show a function is increasing. So to show decreasing, you show f prime x negative, then you can say it's decreasing.